My man, today is really an exciting day because you are going to most important part for me, I think, for now, which is Lagrangian. Where when you have SDP, semi-definite programming, you first have a primal, after try to find this Lagrangian, and after the dual. And so I think that's the main complicated concepts. So I'm really happy to introduce you Lagrangian duality. So I'll explain you with me. So if you consider a general SDP, which we can call P star, and which is, as we said earlier, we already defined in other video what is an SDP, so that's the same. We just add one other constraints because you can add as constraints as you want normally. So a sub of trace of Cx such that, don't worry about this, trace of Fi of x is inferior to bi or ai, you know what, because we take two constraints this time, and trace of gj of x is inferior to bj, and you can add other constraint, but we'll go with two constraints today. As we said before, difference with linear programming is that the fact that you can add semi semi-definite positive constraints. So x here will be semi-definite positive, which just means all his eigenvalues are positive. So finding lower bounds on P star is easy, no? It's simple. Given any visible x, P star is always like it's easy to find the lower bound, because the lower bound you can just take P star superior to trace of Cx. So trace of Cx is in a way a lower bound. But is there a systematic way to find upper bounds? And that's the answer with Lagrangian normally. In particular, upper bounds on P star could help us understand if a given point x is optimal or not. So to this end, for each constraint of our stuff, so this one and this one, um, and this one also, we have three constraints here. We'll try to define an indicator function. An indicator function is just defined as this. I is for indicator. And so zero if p of x is true, and minus infinity else. So okay, now you have three constraints now. So for each of them, we we will already define them with this. So you replace just p, like p represents your constraints, like p of x is for each constraint p of x, this indicator of the constraints. Oh, so you can rewrite it, and so it's equal to the same, literally the same, sub of x of trace of cx. You do not change the, the initial goal, and just about the constraints on themselves. You just do, so trace is just the sum, so it's just the sum over I of the indicator of the trace fi of x inferior to ai plus the sum of j, same e trace of gg, the x inferior to bj. I recommend you really following this procedure at the beginning. After, you can skip the steps of indicator functions, but this way, because it seems it's not easy for everyone at first, even if it can be for you, it's better to follow the procedure. So yeah, do not divide as I mean like this, yep, and plus indicator about x. So that's it. To see this note that for any feasible point of the general problem, the objective above reduced to trace over Cx, and for any non-feasible point, one of the constraints will be violated and lead to an objective value of minus infinity, which is not optimal assuming the problem is feasible. So, well, anyone, just skip what I just said. I speak for nothing, but so here is our stuff, and now we'll just take each of those constraints and rewrite it with this definition of the indicator function. So typically, if we take this first one, the indicator function of the trace of fi of x inferior to ai of x, so you see if we put ax under the constraints between both. Anyway, so it just equal to inf, like each indicator function can be seen as an optimization problem. So yeah, just think that that's the definition of the way of your stuff. So here, because you have an inequality, you take something superior to 0, ci, if I'm not mistaken on the number of the letter, of ii. So you take this minus this right side minus left hand side, RHS minus LHS. Yeah, so that's it. After you have this, now it's equal. The second one normally you define it that well, I did. That was stupid from me. I just did not write the correct equation. So yeah. So yeah, you just the same here, huh? So yeah, you have this. Once again, I went too fast in my head. Not writing what I was. Oh, bro, what are you doing? it was so, oh no, so okay, it was not time, it was okay. Okay, pg of x, so you can take lambda, but this is one because it's inequality and not inequality. You can equality instead of inequality, you can take lambda being into lambda j being into r, and so it's just lambda j of bj minus trace of gj of x. And so the last one, because we have three constraints, 1, 2, 3, and we define them here, here, here. So I just E, and as always, you just put the constraints here. Just equal, and you have semi-positive definitive stuff. You just write, and as you saw, the goal is to the indicator function give you the opportunity to go from sup to inf, and that's the trick about the Lagrangian, like inf of sup or sup of inf. We just saw it after anyway. So now the procedure, first you write your what is they give it to you, which is this with the constraints. You write the indicator function of it, so it's literally replacing. You can even skip this step, and directly go from to here, and put I your constraints here on x, and you do it for this, and this, and after you do the calculation. So that's the step we're into it. And so yeah, for when you have semi-positive stuff, so try to correct. So this symbol, you can just add another positive infinite matrices, and that gives you the indicator function. Okay, so now we have our new problem, which is p star is equal to, so I told you, so we just write it as before, we just write this as before, but we'll replace all of this. So we have sup of x, because that's here, but now we have also inf of those three constraints. So phi psi equals 0, lambda j being into r, and y being semi-positive definite. And so yeah, you just try it. So this does not change because it was the goal and then the constraints, trace of the x. Now those three stuffs here, we replace it with those three stuff. This, and this. So trace of the x plus, as we saw, it's the sum over I of the stuff. So this we replace by this. So phi I a psi ai minus 2 trace of I. Okay, so plus sum over j of lambda j bj minus stress of gj of x, and the last constraint. So you see here, you don't need a sum for the sum if it's not a trace. So you just add this plus trace of yx. Okay, and so that is called the Lagrangian. It just a function saying that you have this new stuff, so you have x, and this three stuff, three new variable in a way, lambda j y, and you don't have to write the just like you take all of this and you put it here. I'll do it for pedagogical purpose, but I think you understand me. Ah, that's Lagrangian. Okay, that's Lagrangian. Love this. Okay, so that's called Lagrangians, and the three stuff exactly. They're called dual variables. I told you it's variables, but the real name is dual variables. Maybe because the stuff of have our primal, which is this in a way, I think. After you try to find the Lagrangian, which is this, and after you find the dual. So yeah, not to get our upper bound, we can do the full in min max swap. So we know like p star is just sub of x of n of the Lagrangian. I'm redoing all the steps. This way you can understand it well. So okay. Also Lagrange, which is x psi on that j y. So yeah, um, rearranging the terms, we like the super is that inferior to the, how to explain it to you? The superior of the nth is always inferior to the nth of the sub. It's easy to understand normally, like it's intuitive. But I just want to be sure you understand what you're doing. And so yeah, the sub of the nth. So you know that's the best of the nth, we'll say. Let's say this is a stuff, so there is a lot of nth, and so that's the sub of the nth, you know? That's the best, biggest of the nth. And so here, that's the nth of the sub, because the sub, like super to this line. And so as you see, nth of sub is superior to sub of nth. So that's why we can switch like this, having what we want about our Lagrangian, and we can switch stuff. So yeah, that we have this, what is our new problem? So rearranging the term into Lagrangian. So I mean, if we rewrite this, so you see, we as we saw before at the beginning, that it was easy to find a lower bound on P star. On P star is simple, given any x it's superior to this, so it's in a way our lower bound, and so we just switch now and to find an upper bound with this trick here. And so yeah, all of this was for this trick. So let's rewrite it now. We just write this. Maybe I'll write it here it will be easier to visualize. So it's equal to inf of CR equal to 0 lambda j into R, the y being the semi-positive definite of sub of x. And we just have to write this. So what we can see here is that we can maybe we factorize by the trace and after by c. No, by the trace and after by x because we have x here. So maybe we can isolate the steps that are not related to trace and c. So we have this by trace on x. So we have this sum of I of this, sum of I of psi I, and here sum of j of lambda j bj. And so all the other stuff, it depends on the trace on x. So we can factorize by them. Between plus trace over x of c minus a sum of I psi I phi I minus sum of j lambda j b, so minus sum of j lambda j gj plus y. So that's it. And so maybe we can pass the sub of x here because all the stuff of x are here. So we just switch this because all x is here. And so we can just try to reapply this indicator function. Now, because we have sub of x of trace of x of the stuff, so we'll go through my boys. That's really important topic, if not the mainly one, that is the most important. Lagrangian is at the hertz. Sorry, so we don't have this then. Have the indicator function. As earlier, we had this. In your disk, we focused on this. So we focus on this. Just write it like this. For three constraints. Oops. Yeah, so I put the 0 here. For three stuff. CA on the edge, A on the Y. So we just replace the indicator function trick, explained above, but now to the minimization over of x. And so putting all this together, we just have proof that B star primal dual. This P is for primal, primal. And so we have lower bound primal. And so now we found an upper bound on the primal. And so for doing it, we find the indicator function. We transform it. Thanks to the indicator function, we'll find the Lagrangian. We switch inf and sub to find an upper bound. We write it again. And so primal, which is this. No. This is our primal. And we just show it inferred to this, which is just this after calculation. And so it's just fine. We put our constraints. There's two ones here. And the y will be after because it's a PSD, so we'll put it at the end as here. Y means 0 to 0. well, not now we will not put it, but okay, anyway. So we have this. Well, maybe yeah, I can. Before doing this, I'll try to explain you something. So yeah, maybe to explain you better about it, I didn't do this first. I want you to understand why we do not choose this y here. It's just because, in fact, here you have this condition on the indicator, and that's it's equivalent to say that c minus sum of I. C I of I minus sum of g of lambda g bg is equal to minus y, but y is superior to 0, so that's less or more the same than saying that same minus, like, at least that's the implication is this. It's also true to write this then, that it's inferior to 0. It's inferior to 0 because y is by the semi-definite, by def as we write here. So you can write this. And so because you write this, you don't have, it's like you don't have constraints on x. It's just like we could try to create new constraints knowing the constraints on y for the search that in the dual, but we cannot retake exactly the same formula. And so I will just, and so now you see we have this new constraint. It's not depend on y. So as I rated earlier, we found our dual, and so it does not depend on y. Try to find a new constraint which does not depend on it. So it's just this, and so we have this, and so it just this are constraints, sum of a phi a plus the sum of g lambda g b g, and so our constraints. So that's this, and this we cannot retake it as this, so we find this trick to rewrite it, and we found this. So the such that in just this. Well, it was, well, I wrote shit from here. No, it was a G. Okay, GG. Here, so it was a GG. JG. So here two, here two, and here two. And so we arrive to here. And then GGG, which is sphere to, to 0, because this y is this, so minus y is minus this. So we just have our constraint to find this. And because of this, we didn't need to write this. This, as we said, we moved on thanks to the constraint, and so you just have this last one, which is this. And so here we find our upper bound. This new optimization problem is just another SDP. In particular, it's known as the dual SDP, so we call it D. This gives us our primal pair of SDP. So yeah, now we had our B star at the beginning, which is this. And so we have our dual here. So this is primal, if I remember well. It just this, what we have at the beginning, and the dual, so that's a primal. So what we got in the dual, just this. Is square to 0. No matter I. And so yeah, going for we went from the primal to the dual, sent to the Lagrangian. Yeah, that's the 3 steps. 1, 2, 3. That's it.